In this project, we will be measuring the horizontal displacement of the red pool ball across the pool table. We are going to call this the trigger ball. If you take a look over here at the x versus t graph, you can see that it starts at 1.8 seconds. This is the amount of time the ball is in Brooke's hand before it starts its path of motion. In addition to that, if you look at the meter stick right here, you can see that the ball's total displacement is 0.6 meters. Now we'll watch. If you take a look at the Vx versus t graph over here, you can see that the ball experiences a slight dip in velocity shortly before hitting the rest of the balls. This, we think, is due to the fact that we observed a small dip in Kaylee's pool table right here at this point. The trigger ball transfers its torque and its energy to the rest of the balls as it strikes them, causing the balls to then disperse in the various directions.
We also learned that to get the most acceleration on the ball, you must hit it tangent or perpendicular to the table, not pushing down on the ball at an angle from above. As you can see in the video, this relates to the conservation of energy, which says that energy cannot be created or destroyed, only transferred. When the trigger ball hits the pile of balls, its energy is transferred to the other balls, making them move.
Also, there are multiple forces in our project, including the following things. Gravity is acting downwards. The normal force of the table is acting up. The applied force of Brooke's hand is pushing the ball, and friction is created as the ball travels on top of the pool table.
Once the ball left Brooke's hand, it wanted to stay in motion. This relates to Newton's law of inertia, which says that an object in motion wants to stay in motion, and an object at rest wants to stay at rest. As we learned in the previous chapters, objects rotate around their center, whether there is mass there or not. This is called the center of mass. In our project, the pool ball is traveling in a linear fashion as it travels across the pool table.
Potential energy is zero because the ball does not change its height. Since the ball is moving, it has kinetic energy. The ball loses some of its kinetic energy to friction in the form of heat and to the rotational energy given to the ball.